Hello, everyone. I'm Michele Macchioni. I'm going to start this GTA talking about post-processing. Let me just start with a brief agenda on the content that we're going to touch base. First of all, I'm going to open the dances, if you will, with the panel removal from HyperMesh work, especially the post panel, and showing you the progresses that have been made, and I will do a little demo. And then I will hand over to Varun, who will take over on the hyperview part of it, showing you updates on the quick hotspot tool, the strain linearization, and showing you other enhancement. Little demo, I believe, also from Varun, and then showing few slides on the automation side, especially the HWC part, and then we will move on the QA session. First and foremost, from all the PM team, our big thanks goes always to the development and QA teams, without whom all this work not gonna be possible at all. It's always tough and challenging to be on time with the planned content, and this is just possible because we have a fantastic team of developers and QA all working together to get these things done. So again, it's no rhetoric. I really appreciate working with everyone with these teams. They are great guys. Then I will start with the HyperMesh post side for 2022.2. Our major focus have been on the work with respect to the panel removal from the post side, from the post panel. And if you see the look and feel of the panel in 2022.1, this is what you were getting, or you still have in the current release, and what is going on in 2022.2, showing actually here just the OptiStruct profile, because for the others you will not even see anything more. We have basically migrated and deprecated all the other functionalities. The big work has been done first and foremost on absorbing the HyperMesh res file, actually the OptiStruct res file, and all the HyperMesh res into the mainstream workflows that we recently integrated in the HyperMesh part of it. As you know, we are now supporting results with the streamlined workflows, with plot controls, and so on and so forth. Thus, the contour, the vector, and the deformations are now, let's say, moved, streamlined, as I was mentioning, in what we call the HyperMesh post results workflow. What happened to the other? On the fatigue side, which was supported still with the res file, we agreed from the PM team to completely remove it and basically have a major push towards the HyperLife workflow, because HyperLife is definitely our solution for what concerns fatigue processes. When it comes to the transient, which means the animation, I know this is going to be a big deal. We decided consciously to remove the workflow and the panel, and we are really aggressively working to have the animation full-fledged support in HyperMesh post for all the three modes, meaning transient, linear, and model animation mode. There is a team working on it, great guys. I have already seen a lot of progresses on the transient side. This will open up as well the possibility to actually expose, excuse me, all the new results workflow, not just to the implicit solvers that we are already supporting, meaning these Nastran, OptiStruct, Abacus, and Ansys, but finally unleash the full coverage of HyperMesh post also for the explicit solvers, obviously Radius, Dyna, and PumpCrash. Last but not the least, also the summary panel got removed. I had touched base with Kevin Mason on this side. Most of the functionalities are currently migrating into the other, let's say, mainstream tool like MAS, Model Checker, and so on and so forth. So we basically want the users to start using this new tool. So all the field team will have to support this type of, let's say, migration. As you know, the REST file has also been instrumented in the past, and it still is, for the workflow of the contour load. And in 2022.1, you still see a what's called panel-based workflow, where you select the load cases, and then in the background, a REST file is generated, and then from the panels, one can display the relevant fake, if you will, simulation and data type to showcase the contour, which is then displayed on the model. We basically hybridly migrated these functionalities into a context-based workflow. So the REST file is still generated in the background. If I recall correctly, actually this workflow has been, let's say, coded by the poll leader through TCL, which is very valid still. We are now using the context. We are still parsing the REST file, which is generated in the background, and basically avoiding the need of popping up the panels. Obviously, this is not the final solution. This is an intermediate one, because we want to migrate into a full support of a model-based, let's say, contour workflows with the same logic of the plot controls, but instead of having results as a source of information, we will have the model as a source of this information. So we shall be able to display any type of data type, data name from the model data, being these loads, but also properties or materials, and any other metadata in form of either a contour or a vector eventually, or even a marker or annotations in the future. This is still up and running, just to give you guys a forecast of what is going on. That being said, since I know that legacy, we're still bound to legacy, we're still bound to eventually also legacy script. The legacy script, which were based on the commands bound to the REST file, are still valid. The commands have not been deprecated. They can still be used. I'm just pointing to a few of them, like the analysis file set, the star contour plot, and so on and so forth. These are still valid. And we also have been created an undocumented API, which will return a list of information when you have been imported a REST file, which is the hm_get simulation info. And here, and you will get the slides, obviously, I'm just putting here a few snapshots of a code that can be used, and I'm going to demo, where you can see I'm basically setting a file to open, which is the REST file, and then I'm going to use the analysis file set to make it current, to basically load inside the HyperMesh database, and using the get simulation info to populate the siminfo list, and then use the standard commands like input simulation to define the subcase name and the data type, and then use the contour plot. Actually, these API, it's, if you wish, also an RFE, depending from a certain perspective where you're looking at it, because in the previous build, you were not able to parse the REST file from any API and basically recreate possibilities to loop between the subcases available and the data type. This was baked in the panel code. But that's, if you wish, just a patch. I know from my previous life as an application engineer how important it is to navigate the customer from one workflow to another, but I would still kind of iterate on the mantra. So let's try as much as possible to avoid the legacy and sell to the customer the benefit of the new workflows, especially as we know REST file is something that is not anything that we are going to support in the close future and the far away future. Even OptiStruct has stopped pushing REST file as automatically output, so you have to explicitly write in the case control that you need the HyperMesh REST. So definitely the push is to move to H3D, OP2, XDB, ODB, RST for this type of activities. Okay. So, and with that being said, I'm going to briefly demo exactly what is shown in the slides before handing over to Varun, using exactly the same model. It's a bullet model, which we're going to make it public. Everything I'm showing can be shared with customer and so on and so forth. I'm using latest mail line available of 2022.2. And as I mentioned, we have a model loaded. Usual workflow is to go to the results input, and then automatically as an object profile, we're going to get the H3D OP2 or HDF5 supported, but we have also the HyperMesh REST as before. But now if I hit open, the first thing that I'm going to get is a little warning message, actually an information message, which just point out the fact that the REST file are not supporting ID pool, meaning for those that are not aware of ID pools is the fact that you may have entities, elements which have the same ID but shares different pools, and our usual H3D, OP2, and so on, they support the possibility to assign proper results to elements having the same ID but different pools, like shells and solids or beams and MPCs and so on and so forth. In this case, the REST file doesn't have it, so we are tweaking the underlay infrastructure to support the absence of ID pool and showing a little warning message to say that there could be some hiccup on the OP2 or H3 that you're going to load if they also have ID pools. Actually, I've been testing pretty thoroughly all the several options. I haven't been found really any specific issues, but it's kind of being conservative on showing this to the users. But as I mentioned, everything is there available in terms of load cases, which are stored in the REST file, and then you can move on with the standard approach of the contours and the vectors and the deformations. Obviously, tensor wasn't there at all in the data structure of the REST file, but you can use contour and vector at your convenience, and you can use the standard plot control workflow to display anything that you need. You can add different type of, let's say, plot controls, add your max principal. In this case, you can plot it. And then usually in the REST file, the values were automatically pushed to be corner or, let's say, averaged or bound change from the elements to the nodes, right? So everything is available, same for the deformation. And then you can just change the load case as you were used to do. And this allows you also to keep on adding extra results files like OP2 or H3D and so on and so forth, which was not possible in the with the standard panel view. Now, obviously, when I show the panels and we go to post, as I was mentioning, we just have the leftover of EOS Smooth, which is under the work to get also this absorbed by new workflows because the goal is again to get rid of all the panels for the release of 2023. This is not part of the webinar because this is post, but I want just to refrain how much key is to get rid of panels, and it's not just because we are definitely pushing all our users to move to the new user interface and user experience. This is vital and crucial to have HyperWorks, let's say, migrating to a single process. This will allow us to reach better stability, better performances, and above all, since a part of this webinar will also be part of automation, this will allow us to be able to expose full-fledged the Python support API, because definitely we need a single process to be also in a single interpreter between the HyperMesh, for instance, database and the GUI of HyperWorks, right? Last but not the least, I want to showcase you. So now let me just clear it out. The contour load, as I was mentioning. So this is still under the analysis page. The workflow in terms of usability isn't altered, so you still have the old browser. But now when I accept a dedicated, let's say, little context is showing, and now you can see that you can pick up the simulation type, which are the load cases that are being generated, and then you can contour it. Still, you're getting the old legend and things like that, obviously, right? But I was mentioning no panel is popping up, and we are still using the REST file infrastructure. And I was mentioning this is the way you would get it. So let me just give you a small example. Let me actually get rid of this file just quickly, showing you the TCL console. So now I am set the file tk and get open file. Actually, there is a typo here because the G has to be small. So let me just modify it before you get it to the web from the webinar. Now I'm taking the REST file. Now I can set the analysis, which basically it's the legacy way to import it. Then I'm setting the simulation info from the parsing, and now you can see that a list is created with several subcases, and then for each subcase you have the other, let's say, data type which are stored in the REST file, and then I just need to set this simulation info here, which is basically, let me just put it here afterwards. I'm just going to contour plot the magnitude, right? And then you still have the displacement field shown in the tool. Nothing extremely fancy. I just thought it was a good, let's say, safety lane for those that are maybe freaking out. Okay, how can I get it now that the panels are gone, and so on and so forth. This is available. I don't think there is any point to push it as in any official documentation and hand over now to Varun to move on with the hyperview part of it. So thank you guys for your attention so far.
Thanks, Michele. So let me jump straight into my presentation. I will start with some important updates first in HyperView. So the first feature I want to highlight is the quick hotspot tool. I will also show a demo of this tool. As the name implies, we have added this tool to offer a quick and easy way to find hotspots in just a few clicks. Simply click on this lightning icon in the ribbon, and select the bunch of nodes and elements that you're interested in, and the tool will automatically locate the max or min entity within that selection and attaches a note displaying this information. So because the goal is to do all this in as few steps as possible, several things are pre-configured automatically. So the first thing you will notice is that the entity type is automatically set based on the contour that's plotted on the screen. So if it's a nodal contour, you would see the entity type showing as nodes and so on. And then the tool starts in an auto create mode. Basically, this allows you to find min max within a window. So just drag a window on your model and it would locate the hotspot within that window. But if you want to select entities using a different criterion, you could turn off this checkbox and use other options such as selecting by part or selecting by material and so on. And another nice thing about the tool is it has an options menu, which basically lets you customize the display a bit. Before running the search, you can set things like the text you would like to see, the font, where you would like to see the note on the screen, the color of the note, etc. You can pre-configure this before running the search. And as you can imagine, we are already working on the possibility of letting you save these settings into a template. This will come in a future release so that you can have different templates for different types of searches, which you can save and retrieve and reuse. So the whole goal of this tool is to offer you a way to do a hotspot search very quickly without going through a lot of steps. As you know, we do have the full-fledged hotspot finder, but that tool is for a more detailed search where you can filter out entities based on different criteria. So this tool is a more quicker and basic version of the hotspot finder. Let me just jump into a demo first before I come back to my presentation. So here on the screen, you do see a model, just a standard model where I have, a contour of a stress plot. And let me show you how the quick hotspot tool works. So as soon as you hover over this hotspot finder icon, you would see a lightning icon, a satellite icon here, which you can click to bring up the quick hotspot tool. And like I said, since the contour that I have on the screen is element based, the entity type is already set to elements, so no need to set the right type. This is in auto create mode already. Let me just show you how to use the options menu. So you can set things like the criteria that you would like to run, max or min. The node type can be static or dynamic. Dynamic means it would update with the animation. You can configure, the text. By default, it shows the ID and the value. You could configure it to whatever you want to see on the screen. You could change the font. You could have the note arranged in any location, placed at the entity of the model, and so on. A bunch of screen anchor ops. So very similar to the notes tool, but this is more tailored to hotspot finding. And the text of the note also, or the color of the note, can be configured as well. We allow three options. You can set the text, border, or the fill colors, uh, either user color, or you can have the component color or the contour color based on the contour color. So let me just play with a couple of settings. Maybe I will change the font, Arial 14, and I can maybe put the color to contour color. Okay, and once you're satisfied with the options, this, since I'm in auto create mode, it works on a window selection. Simply drag a window wherever on the screen. You get your note placed off the model with the font that you've set and with the color that you're interested in. And as I mentioned, the notes are created here. They are permanently created. They are available in the notes folder. So any node properties can be modified later after running the tool as well. And you can save and export these things into a session file. And I mentioned, like, in the next release, we are thinking about the possibility of having the options to save these settings and reuse them in future searches. Let me move on to the next update. This is an update to the extract and linearize tool. As you may know, this tool currently supports a couple of methods in the current release, which is the extract data and the stress linearization method. Now, based on multiple customer requests, we have extended the tool to support linearization of strain data as well. So obviously, it requires the presence of strain tensors in the result file. Once this data is available, we basically use the same math and formula as stress linearization, which is extract the value at all these points along the path. And from the extracted values, we calculate what is known as the membrane and the bending strains. And then this data you can visualize in the form of a hypergraph curve, or you can export it into a CSV report for further processing. So as I said, the tool was already supporting linearization of stress data, and the same formulas have been used to work on strain data as well. Apart from this, we have also introduced an option to specify the x-axis under the plot options section. So typically, the x-axis would be the distance of each point along the path, and the y-axis would be stress or strain. But if you want to see maybe the x component of the distance or y component of the distance, or you want to see the x or y coordinate of the distance, you have all these options now that you can specify through the x-axis plot option. Moving on, there are a few other useful enhancements in this release that I would like to bring to your attention. So the first one is in HyperWorks, the new user interface. So under preferences, we have two mouse control presets now available. One is the default mouse control, which works in the new interface style. And then there is also the newly added legacy preset. So this will be supported going forward from this release. The main benefit of this legacy mouse control is that it will bring back some functionality which was available in the um, old interface, such as circle zoom, vertical zoom, um, tumble, etc. So presently they are available under the legacy presets. We do plan to expose these functionalities as well for the default preset as well. And one thing to note is at this point, you cannot customize the individual mouse controls. So you just have the option to either set to default preset or legacy preset. But we are working on the possibility of allowing you to customize any of these individual mouse controls in a future release. Then coming to user-defined systems, we have exposed some additional options in the GUI to define your rectangular coordinate systems. So by default, Hyperview supports the XXY method when you're picking three nodes. The first node would be the origin, second node would define the x-axis, and the third node would define the xy plane. We have now added the other combinations as well. So any of the other axis plane methods you can choose to define your system. And then the next item is, based on popular request, we have reintroduced the spinner arrows, the up and down arrows in the browser, which will allow you to easily cycle through your subcases, steps, and models. And then lastly, in the measure tool, we have introduced an options menu. This will allow you to pre-configure certain settings before you create the measures. So things like the font, the color, format, and precision of the measure text that you see on the screen. These can be configured before you actually create the measures. And this information, is also something that would be, saved to the session and restored. So this is all on the HyperView, the core HyperView product itself. I also want to mention a few notable features and enhancements on the solver interface side. So the first thing to know about is support for a new user interface, a new solver interface. So we have added the option to load and process EDM results directly in Hyperview. So that would be the EDM native outputs in HDF5 format. So you simply have to load the DEM file as model and result, and once you load, you can do all the basic post-processing in Hyperview, like playing the animation, contouring certain results data, and so on. Just showing you a couple of animations here of what you can expect. Automatically, we will read the particle size and render them on the screen in the proper size and shape. So please, check it out. Then in terms of enhancements, obviously the ANSYS version support has been upgraded to 2022 R1 in this release. And then coming to Nastran, we have added support for a few new results. So initial contact status and the glue contact force results are now supported in OP2 and HDF5 formats. And then acoustic pressure results is also supported across all the formats. So with that, let me jump over to updates on the automation side. As you know, one of the main pillars of our automation functionality is the HWC, or also known as the HyperWorks command language. So here I will mention a few interesting enhancements in this release. So first one would be support for multiple models. So we have added a command that you see on the screen, HWD model apply, which basically applies some actions on all the models in a window or across a selected range. So you can have multiple models, in Hyperview overlaid, and your actions, either in the first phase, we are covering these four commands: show, hide, mark, color, and attribute. So any of these commands, if you run on the active model, it gets automatically applied to the selected range of overlaid models. So the main benefit is obviously improved performance, because you don't have to first apply it on the active model, then switch the active model and rerun the commands again. You don't have to do this looping over the models. Simply set this mode, and then any action that you do on the active model will automatically carry over to the other models. I would show a little video of the feature in a later slide. The next one is traceline curve support. So creating traceline curves is now fully automated. You could do it with just 2 lines of code. Basically, one command is needed to add the traceline nodes, and another command is needed to specify your curve options. And just as a reminder, the traceline functionality was enhanced in 2022.1. So the core now supports ability to create curves. And what we have done now is add the HWC support for this functionality. And then the other item is that the show, hide, and mark commands have been enhanced to support nodes, measures, and assemblies. So in 2022.1, basically you had one command recorded for each node or each measure. Like if you change the visibility, it would record it for each node separately. Now changing the visibility of several nodes and measures, it will all be recorded in a single command, making the code much simpler and easier to understand. So let me just show a quick recording of this multi-model support feature. Thanks, Stefan. So play the video and I will talk over the details. So here you have essentially 4 models loaded on the screen, 4 iterations in a single window. And what we're doing is, turning off the visibility of a couple of, parts. And then you can see that we are activating the multi-model support for all the models. So at this point, any command you run in terms of hiding or showing or changing the attributes, as you can see, making all the components transparent, it applies across all the models. Changing the colors for a particular component, it applies across all the models. You could also mark components that begin, with a certain label, and then apply a specific action to that component, and it would propagate through all the models. So making it very convenient. As you can see right now, this feature works on a single window, but we have been discussing the possibility of extending it across models, across windows or pages. That would be coming in a future release. And then once you have the commands executed, from the console or script, you could basically copy it and replay it, right? So this can also be done. So moving on to extension supports. First thing I will mention is customized file menus. So you can have customized client-specific entries now in the file menu, and these can be loaded via the file menu using an XML approach. So basically, by referencing the file menu.xml in the root extension.xml file, you could trigger it to run procedures like tk get open file. The main benefit of this is it will allow you to customize solutions, to follow a similar workflow like core solutions. For example, you can use the file menu to, select a file instead of doing something totally customized for the tool. Then on the extension unloading side, you can now unload ribbons, drop-down menus, and toolbars without having to restart the application. So basically, the extension manager uh, GUI has a toggle to turn on and off, and it will simply turn off all your custom tools, menus, ribbons, etc. Instantly. So no need to restart the application. And then we do have also the initialization of global TCL scripts. Basically, this prevents code duplication. So in 2022.1, initialization of client-specific TCL scripts was introduced. But if the user wanted to use the same procedure, um, let's say in Hypergraph and Hyperview, he would have to copy the TCL files 2 times to make sure they are available for each client. But this new enhancement basically makes it much simpler and avoids code duplication. So you just have to use only one initialization TCL file in the root of the extension to load the procedure across all the clients. I think with that, I conclude my presentation. Thank you all for attending, and I hope you found the features quite useful.